been meaning to make this video for some time. I bought my own RC during COVID, and just the same as many of you out there, I also received this GSO type monorail focuser with the RC itself. It worked for a few weeks, but it was never working satisfactory. So I decided to look at what was causing the problem with the focuser, because to be frank, it is a very efficient focuser, and I certainly do like this monorail design. So I wondered what was holding this back and why wasn't it working correctly. And I discovered pretty quickly that, well, the one thing that you can't afford to do with these Greyford focuser designs is use inferior materials for the focuser bezel itself, and that's what I changed. As you can already see here, without me disassembling this, you can already see that I have a 3D printed what I call a trunnion, a new trunnion to carry the focusing rod, and I'll show you the magic which is inside here, which enables this focuser to work correctly all the time for me without any problems at all. So let's get this stripped down. I would have loved to have made the original video when I disassembled or deconstructed the original focuser bezel or trunnion, this piece, but unfortunately I never made that video. But now I'm back on YouTube, maybe somebody can benefit from my modifications to this focuser, which may allow you to repair your own, and that will save you from having to invest in an expensive upgrade once you've actually bought an RC. Because to be frank, the optics and the truss construction of these GSO RCs is fantastic, and for us amateurs to be able to have access to these quality optics, these quality telescopes, is frankly amazing. It's nothing short of really amazing, and I stand by that. It's a real pity that GSO have effectively, I don't want to say crippled, but hobbled, let's say, hobbled their telescopes as a total solution by skimping out on some really basic design considerations for the focuser itself. But you'll see that shortly as I take this apart. Hopefully you'll see the magic, how I made this focuser work properly, and how you too can also make your focuser function correctly, and then avoid a investment of an additional, let's say, €400 minimum to get a functional focuser. You'll notice also I'm using the Gemini. I use two autofocusers for my telescopes. Of course the ZWO-EAF, but this Gemini also works very well, and I can highly recommend it. Now we have the focuser off, we can remove my new trunnion. If you have a different name for this, bezel, trunnion, whatever you want to call it, then let me know in the comments. We can release the tension a little bit. This is, you can use a adjustable thumb screw here, but this is the tensioner now for my Greyford focuser. Let me undo this other part. What I will do is I'll make the 3D printed trunnion, as I call it, available on my Google Drive, free to download. I hope I just hope it helps people to fix their focusers, to get them working properly. This will not be a long video. Should be quite an easy thing for people to understand once I show you the magic in here. There we go. I think you can already see it. Right, but look at the rod itself. Look how I'm getting a consistent bearing of the rod against the monorail. It's almost a good centimetre. A little bit offset, as you can see there, but it is bearing against the monorail surface, and it is able to focus precisely during the night, and it gives me, well, this galaxy season has given me some excellent images of the galaxies in the night sky with the RC. Of course, I'll put them at the end of the video. But what is the magic, the critical change that I made with this focuser? I hope that you can already see, if you start to pull the rod out, then what you can see is this is all standard. There's nothing changed here at all. This is literally all standard parts from the GSO. I bought nothing new here. But what I have done, and what I did see on some of the more expensive, let's say old-fashioned Crayford focusers, is that they use brass. Brass is the material of construction that needs to be used inside the design of a Crayford focuser. It's perhaps an old-fashioned material now, but essentially this brass block is a self-lubricating metal. It's not too soft, but soft enough that, of course, it's not going to cause any damage to either the monorail itself or the steel bar here in the focuser that it's pushing against. But it's strong enough, and it's self-lubricated, of course, to ensure that we have consistent pressure bearing against the surface here, to ensure, one, of course, that it doesn't slip, and two, that we can get and ensure precise focus throughout the night using this focuser. Now, when you take apart your GSO focuser, what you'll find in there is, disgustingly, is plastic. You'll find plastic bearing against this, pushing the rod against the focuser inside. And of course, that is simply a recipe for disaster. It doesn't work well. It certainly doesn't work well for long, and I advise you to 3D print my my new trunnion here. You need to 3D print this and get yourself literally a small piece of brass. Now, I made this with nothing but hand tools. So all I did was score down the middle with a measurement vernier, and then with an hacksaw just scored that line less than 0.5 millimeter deep, and then you just file it with a diamond, little small square diamond file, to have a V shape. And the beauty of a V shape, if you know engineering, well, maybe some of you use lathes or milling machines to mill a round bar. The beauty of a V block is that it perfectly fits or centers around the rod itself. So that has a little bit of freedom to move, a little bit of play in here to move around. It doesn't have to be, of course, perfect, but it's about 1 millimeter, 0.5 millimeter either side there that it can actually move. And then the rod itself is held. And of course, I've designed these square ends to capture the focuser properly, so you still benefit from all the features and benefits of the 10:1 focusing. But now you have a consistent force pressure using this brass block to push the rod against the monorail. And that is the secret, that is the way to fix your GSO supplied focuser. So this would cost you no more than a few dollars, a couple of euros. It's literally a 6mm by 30mm piece of brass that slots in there. Few hand tools, less than 10 minutes worth of filing this, and you will have this whole assembly ready to go, ready to fix your own GSO focuser. And that is really it. It's as simple as that. Okay, let's conclude this video. And just so there's nothing hidden there, and you all understand how to tune up or repair your Crayford focuser that's delivered with the GSO telescopes. This is the file. It's a needle file, inexpensive. As you can see, it's a little diamond shaped square file. That is literally all you need to file the profile on the block itself, on the brass block. Once you file the profile into that block, you've more or less done. What I also want to point out is when you're filing the brass block, you don't want to go more than, let's say, 1/3 for the V. You want the block to remain above the center line of the focus bar itself. So this is already enough. I would say, let's say, just over 1/3, just under a halfway with the V. So the rod still sits a little bit proud. So then it's pushed or forced against the focus rail itself. And then you will have a working GSO focuser, I promise you. That's it for this video. Good luck with the modification. You'll find the STL file, the link for the STL file with the YouTube video, so you can go and print this. Print settings for this are not that important. Again, experiment with it. I would use probably 50% fill, at least a minimum of 2 walls. You could use 3 walls if you want to make it a little bit stronger. 0.2 resolution, and just print it and enjoy your improved GSO focuser. Thank you.